Welcome everyone. This is the Quant University Winter School series. My name is Sri Krishnamurthy, and I'm going to be hosting many of these sessions. In today's session, I wanted to just introduce you to some of the programming we have in plans for this year, and also introduce you to a new partnership with PRMIA and the AI risk certification program. And I'm going to talk a little bit about some of the themes which are of interest to you, which is primarily machine learning, data science, and the whole area of how do you think about risk in the context of building production-worthy applications. And in addition to that, this year we are hosting many guest speakers from various areas, both from academics and from the industry. And we are planning to introduce some of the innovations which are happening in the field of AI and machine learning, but also focusing on things like explainability, fairness, machine learning security, algorithmic auditing, things which are becoming more and more of the norm when you are practicing machine learning in an enterprise scale. 8 years ago, I started teaching at Northeastern University, and I was introducing concepts of data science and machine learning to my students in the graduate program, in the Masters in Information Systems program, primarily to help them kind of get to see the possibilities. And recently, I was just kind of checking what my students were doing on LinkedIn, and I was surprised, to see the career progressions they've been having and the responsibilities they have taken on and the innovative and the cool projects they've been working on in the last 5 to 6 years. And it's just fascinating to see the world kind of embark on this whole journey of productionizing these cool applications, which were just Jupyter notebooks just 5 or 6 years ago. And with complexity comes concerns. And when concerns are there in the industry, especially when you're putting code in the heart and soul of your enterprise processes, you got to think about it holistically. And what we have done at Quant University is at every stage provided the tooling and the courses required for people to gear up on the skills which are required in that period of time. And in the beginning, we started introducing people to various concepts in machine learning and data science. And we've progressed since then. And the last 2 years or so, we have primarily honed in this whole area of risk. And I've been fortunate enough to work on various projects with my clients, wherein I've seen the challenges of implementation of AI and machine learning projects when you're thinking about productionizing into enterprise scale applications, but also the questions which people ask. And many times, it's not just trying to understand, but also trying to do it the right way. And because we are in, kind of a state of flux because the whole ecosystem is growing, we do not have all the answers yet. And that's where we need to think about it as an opportunity to collectively learn and to practice the things which are of impact when we are building out these kinds of applications. And with that goal, we will kick off the Quant University Winter School. And for people who are new to Quant University, I have a small slide deck which I usually present so that you can get a feel for what we do as a company. So let me share my screen for a second. So Quant University, we started out 8 years ago as a data science and machine learning advisory. We're based out of Boston, Massachusetts, though in the last 2 years, geography doesn't matter. Testament to the various comments people have been putting in the chat window. We have had people from 13 different countries who have taken our courses. We have done workshops in both in-person settings and also in an online mode. In the last 2 years, we're primarily focused on enabling the Q Academy, which is our online platform to help people understand the various concepts of data science, machine learning, and implementation of artificial intelligence risk management projects. We also have various partnerships with various entities, and we basically build in all the complexities into the Q Academy, which is our platform, so that many of the training programs you take are primarily done through a browser. You don't have to install anything locally, and you will still be able to accomplish various learning goals as you go through the projects. Now, in the context of building out various entities, I have had the pleasure of leading various projects in a financial service setting and also in energy setting for many, many years. I used to work for Citigroup. I have worked for a startup called Indica, and also was at a company called MathWorks, wherein I've done a lot of MATLAB related projects before Python became popular in the late 2010 to 12 timeframe. Also, I've had the fortune of teaching in the graduate program at Northeastern University for the past 8 years. And I've also taught at Babson College and at Hult International Business School. And my team predominantly helps me with all the infrastructure on the Q Academy and the Q Sandbox. And we are very fortunate to partner with various organizations and various guest speakers who you're going to be hearing from over the many, many months, who have taken off their time from their busy schedules. And they're participating, supporting the whole mission of education and transparency in the practice of AI and ML. So in today's session, I wanted to kind of draw the attention to the big picture of what does it mean to build out data science applications. And some of it may be an introductory aspect to you, but I'll connect it in the context of risk. Now, when you think about a traditional data science or machine learning workflow, these are many components you'll probably recognize. And I just wanted to reintroduce these concepts to you from the perspective of risk, because when you think about development application, you are primarily focused on getting the data from the beginning, which is predominantly sourcing the data either from CSV files or connecting to Snowflake, or scraping data from a web interface, or getting data from images, video streams, et cetera. And then you have to think about how do I massage the data? How do you cleanse the data? What kind of features can be extracted, which are going to be of importance? And predominantly, this role has been maturing in the context of data engineering, rather than just pure data science at this point in time. Now, then comes the model building piece, which is where a lot of innovations have happened. Conferences have kind of focused on the narrow theme of we're just going to focus on automatic machine learning. We're just going to focus on natural language processing. We're just going to focus on innovations in computer vision, graph theory, et cetera. So this space has become extremely rich. And that's where, the PhDs who are specializing in each one of these topics have focused on figuring out, how do I take all these data sets which have been processed, and what kind of models can we build so that you can predict certain aspects, or you can understand things in a better way if you're thinking about supervised versus unsupervised learning modes. And then this whole area of, well, what happens once the model's been built? Because you don't want the model to just be in a data scientist workbench, right? So you want this model to be used in production, either in the context of, recommending various products to consumers, or if you're trying to understand what people are trying to say, to predict what's going to happen with respect to weather, to understand what's going to happen if certain events happen, and what will the model potentially do? Are we trying to predict the right kinds of things? Is our model still valid? Is it fair? Can we understand what's actually happening with respect to the model? What are the consequences if the model goes wrong? So all these are the kinds of questions which we're trying to answer in today's day and age. And that kind of brings into this side of the puzzle, which is to figure out how can we tune the model? How can we evaluate and look at the right kinds of metrics? How do you think about selecting the right model for the right kind of job? And how do you put these models into production? And how do you think about making sure that the models are usable, and also which does and generates the value for which it was originally built? So I would kind of put all these three buckets in the operational side of things and connect it with this context of risk. Because it's not only that you are scaling it, you are making these components available, but you're also making sure that you are setting it up in a framework wherein you understand the consequences, you're looking at the vulnerabilities, you're quantifying the risk, and you're also putting in the guardrails to make sure that your models are not going to be left in the wild. And in addition to that, you're also making sure that you're putting the right kinds of infrastructure at the right points in time to make sure that you're providing the right kinds of resources to support your team, to make sure that you have the right guardrails, to make sure that the end users are protected, to make sure that all the use cases which you have accomplished through the various research and operationalization, collecting feedback from various users, collecting all the data, building your own IP, is used so that it gives you the competitive advantage. So risk management is not just protecting from bad things from happening. It's kind of building in this robustness and the resiliency program within your organization so that you can productionize your machine learning models with trust that these models are ready to take on the challenges in the real world. So with that context, we've been building a bunch of training programs and tools, and primarily what we do is, first think about education and provide you the tools so that you can experiment with it and you can try out the various components so that you understand, and then you can potentially build out your project portfolio so that you can build out the various examples which will help you kind of understand what's actually happening when you build out these kinds of models. And we provide you with various tools with respect to auditing, et cetera, et cetera. So what I'm going to do is stop here for a second. And if there are any questions, I'll take them now. Otherwise, I'm going to start kind of getting into some of the core materials I wanted to cover in today's presentation. I'll give it a minute. So if there's any questions, please put it in the chat window, or you can raise your hands. And if you want to speak up, please let me know. I will give you the stage, and you can ask a question in a live setting too. Okay, so it doesn't look like we have any specific questions. So let me do this. Let me kind of get into the Q Academy and just show you some of the modules and the way we are kind of thinking about the learning journey, if you will, because this session was kind of a big picture session of introducing some of the concepts. Now I want to tie it to this whole notion of why machine learning and data science have become such popular topics, first of all. So I want to kind of start out by, the ecosystem, right? So, when we think about building out models, initially in the last 15 to 20 years or so, what has happened is there's this whole democratization of building enterprise software. I used to work for large scale enterprises, which had proprietary tools and a proprietary stack, wherein we would build these tools and license out these tools. And the innovation was kind of predetermined in various ways because you had specific goals of building out these products and you had your ways of teaching people on how to use it. But in the last 8 to 10 years or so, we are seeing a huge interest in open source software, right? So, and Python is one of the leaders. And I have switched over to teaching many of my courses in Python, and all the 5 courses we have in the AI certificate program is primarily built on the Python packages so that you can understand the various concepts at a granular level, but also it's universally available and you can apply them in practice as you get back and using them in your real world data sets. And also the encapsulation aspects of it, wherein you do not have to start writing things from scratch. You have established packages. And if you want to do certain things, just Google and you will find a package which is ready to be just installed, and you will be able to use the features in that particular package. So we're going to be leveraging a lot of these kinds of innovations, which are readily available for every one of us. But you also want to kind of look at it in the context of risk, because when you think about enterprise software, you had the safety barriers, you had the guardrails wherein people were creating these platforms, and you had testing, which was done exhaustively, and you had the APIs, which were readily available for you to use and documented and supported, and you could just go and install and use your packages. But in an open source realm, whenever you're using things like Python, you will have to think about building in the infrastructure and the guardrails for yourselves, which means that you have to be aware of what the language supports. You have to be confident about the amount of testing which has been done for that particular package, which has to be done comprehensively in the context of, well, how many other people are using it? Who are the contributors for this particular package? How transparent, how many updates are happening on a regular basis? How are they addressing bugs? If people are reporting bugs, when will it get fixed? Is the code completely transparent? Can you install and test it on your own? And what level of support will you be able to get from the community? So all those kinds of questions needs to be asked, especially when you're kind of building out things in a production setting. And then finally, you have to think about if you're daisy chaining all these components and building your own workflow, what aspects of it needs to be audited and maintained on a regular basis. Because now that you are integrating many of these tools into your whole ecosystem, you own that stack. And when you own that stack, you cannot just blame a Python developer or an open source developer saying, hey, I just took this package, which was readily available, and I used it, and we saw this error. The impetus is on you to make sure that you have tested, you have validated, and you've verified various aspects of the pipeline, and you made sure that the specifics of the model risk has been completely addressed within your ecosystem, so that before you actually deploy your products. So what we have done is we have kind of created a 5-step process on how to learn to build out these kinds of applications. And primarily, we are thinking about what are the kinds of tools someone would need to look at it, data science and machine learning applications from a risk perspective. And I'm just going to share some of the materials, or like the tooling which we typically use in a setting for our students. So let me just kind of walk you through the certificate program aspects, and I'll kind of give you like the big picture of why we decided to implement it in this way. First of all, when you think about machine learning and data science, the expertise has significantly become common through either graduate programs or certificate programs we have in the industry. But we want to have some kind of a good foundation, because it's not just sufficient for you to be able to understand the constructs of the Python language. It's important for you to understand what packages are optimally designed for what use cases. So there is a package selection criteria you got to think about. You also have to think about the ways in which you can interface, the ways you can extend, and many of these have dependencies. So for example, if you're going to be using scikit-learn, so then scikit-learn will be using other packages like NumPy, or it may be interfacing with, for graphing, you may be using matplotlib. But there are also innovations. For example, when you're visualizing data science related applications, you could potentially use Seaborn. You could be using matplotlib or Plotly, or so there are so many other packages which are readily available now. So depending on the use case, you may have to do selection of packages. And I'm a big proponent of making these applications available from an end user's perspective. So we use a lot of Streamlit, which is a great package to use if you want to deploy applications. You don't have to build out the front end code with HTML and other tools to make these products available. So, for example, when we are kind of sharing various use cases with respect to applications, so we make these tooling available so that you can actually access many of these applications in the context of a browser. So you will be able to try out. For example, if I wanted to launch a sample credit risk application, if you will, so we will be able to run it either through a Google Colab notebook so that you can try out the various aspects in Google, or you can potentially launch an application which is going to be in Streamlit, so that you will be able to try out various aspects either through demos or through hands-on exercises, wherein you will be able to try out different things. So just to give you an illustration, so this is a machine learning model for interest rate prediction, and it leverages 3 different algorithms. From an end user perspective, you don't need to know any Python to actually use this model, but the models have been built in Python. The APIs were created using Fast API, which is, again, a Python package to wrap your models and provide an API-based interface. And this model was built, was accessed using Streamlit, which is, again, another Python-based package, which was used to call these other APIs. And it's all being served on the cloud so that you don't have to do any installs yourselves. So I hope you can understand the maturity of the language at this point, because now, even though we are using Python for various applications, the use cases are different. So for this particular use case, we are expecting an end user to just have a visual interface wherein they're going to be using levers to try out the model, but the model was already built, was tested, and completely baked in using various packages. And here we use TensorFlow, which is another Python-based package. And this is using scikit-learn, and this is again using scikit-learn. So we used a couple of different modeling packages for building out the models, wrapped it up using Fast API, and then interface it using using Streamlit. So it gives you an idea of the ways in which you can build out your stack for testing purposes. And many a times, what you'll have to do is think about well, now that I have my models ready, I will have to test it. And I have to make sure that I can benchmark it with various other applications. So let me show you another example. And so this was a demo example we built when we were presenting for a model interchangeable format called Onyx. So we were trying to figure out, just to do the benchmarking, how would we be able to compare different APIs? And we took the source code from a sample application, and then we added more functionality to it. So here is an API we have built in Python. So this is a simple digit classifier. So I can go in and type in write out things, and it's going to tell me based on the different APIs what digit it is. It's doing identification on the fly. So here we are using a generative adversarial network called TF-GAN. So here we are using an Onyx model, so wherein somebody took and built a model with maybe MATLAB or maybe Python, and then extracted that model into Onyx. And then this was different versions of the same model. So we had using Onyx version 1.3, and this was using 1.2. So here's a simple graphical user interface, which lets you do comparison of different kinds of models using a front-end tool, so that you can actually access the models which are running behind the scenes. So you may have to do these kinds of benchmarking exercises, especially if you are going to be building your own tools, but you're benchmarking against different applications which may be available as APIs or may have been written in different other tools. So to make sure that your models actually work, so you may have to think about stress testing, potentially doing scenario testing, potentially doing what-if analysis, and trying out different scenarios so that you can test out your various models. So the whole notion of building out models is not like a streamlined process wherein you start from data scraping to building out the model. So there is a lot of selection which goes behind the scenes as you're building out your pipeline. So you have to be comfortable making those design choices along the way so that you can build out the thing. So that's kind of the big picture notion of these first two courses, wherein in the first course, we are trying to understand the ecosystem of Python and look at the various packages which are available so that you know the strengths and weaknesses of different packages. And you also get a comfortable feel for building out your applications. And the second course focuses on building out different kinds of machine learning applications. And here we have baked a bunch of different case studies. I showed you the credit risk application, but there are also other applications on unsupervised learning, synthetic data generation, some natural language processing, and various aspects of how do you think about responsible building of AI models as you're leveraging. And all of this was written in Python. The source code is readily available and the testing is readily available so that you can try out these models. So now that I've kind of given you the model building piece, so the third thing you'll have to start thinking about in the context of risk is, well, how do I frame this model risk management question for machine learning models? And that's a very important question. And it's being asked not only in the software industry, but also in banks and in healthcare industries and various places where you are currently thinking about deploying machine learning models. In fact, the OCC released last year a whole handbook, and they did touch upon various aspects of risk management. NIST hosted a bunch of sessions late last year, and they even have a draft document on AI risk management, wherein various themes are discussed. And now the question becomes, well, what does it make sense when you're thinking about building out model risk based application, based questions? What kind of questions do you ask? And things about life cycle management, tracking, metadata management, scaling, reproducibility, interpretability, testing, measurement. All these are questions you would want to ask when you're thinking about building out different kinds of applications. And what we have done is we have taken, based on various industry surveys, based on our experience, we've kind of put together a framework called as a decalogue, wherein we focus on the 10 different themes which you want to ask questions about. And to make it more pragmatic, so we give you a whole framework on this is how you would potentially look at model risk and looking at a whole case study. So we give you access to a sandbox, wherein you can try it out in a sandbox setting. So let me kind of show you the same credit risk application, which I showed you a minute ago, but now structuring that in the context of a whole enterprise workflow. So here, when you think about an assessment of a model from a risk perspective, so you have to now start looking at, well, what are the key components? And we have kind of bifurcated into like 4 different components. One is this notion of model lifecycle. So kind of building upon the picture I showed you before, wherein you had to think about the data, where is the data coming in, and understand the aspects of the data. And that would be something wherein there are packages available. So for example, there is a package called as facets, which could be used to understand the various distributions we have in the data. There's another Python package called as pandas profiling, which you could use. And if you use that, you will be able to generate a nice report like this, wherein you could bring in your data and understand the variables, the observations, the different variable times. We didn't have to write much code to do this. There is an established Python package available, which does most of the reporting for you, so which can give you all these details, which you can consume and start working with it. And all these packages are all coming from the open source realm. It's easy to integrate and use, and it gives you a good way of visualizing the different aspects of the data. So now that you have a good idea of the data, what we will do is we'll start looking at the model. So in the modeling side of the story, what we have done is we have, as you looked before, so we have built out the model, and then there is this notion of model cards, which we could use, and this was automatically generated. So you could basically create the artifacts in the in the modeling framework itself, and you can generate these artifacts so that you can evaluate the various performance metrics as you're building out your model. So from a risk manager's perspective, you may have certain metrics you are constantly monitoring, and you would want to make sure that these are kind of implemented in a good way. And it also kind of goes into this whole notion of 360-degree overview of the model, wherein you may have to factor in explainability, fairness, and various aspects. So that's where you could look at multiple tools which are available for explainability. So there are so many open source packages available right now. All of them use Python again. So you have the ability to kind of fire up an adversarial robustness toolbox or AIX 360 or Interpret ML. All these are completely available for free. You can download and try it out. Similarly, for fairness and bias assessments, there are multiple toolboxes available and packages available which you can which you can try out. And the same thing with security. So there are so many tools available. So what we've done is we've curated the ones which are popular and which have robust functionality, and we have kind of integrated it into the toolboxes so that our students can try out various things in the context of building out applications. And we've curated experiments so that they can hone in on certain themes as they're kind of understanding the notion of model risk and assessing various aspects of it. And then also machine learning monitoring is becoming an important area, especially in the context of understanding drifts and concept drifts and data drifts, and making sure that the models are fresh enough when you're trying to deploy. So from a risk perspective, you want to make sure that your models are actually contextually important, usable for the use cases you have. But also you may want to make sure that the data which is driving the models are also coming correctly, and then you want to kind of capture all the various metrics. So we have kind of integrated some aspects of dashboards so that you can observe the various kinds of metrics. So from a governance perspective, there are so many elements you may have to think about, like what is our classification of different models, what kind of organizational structure do we think about? What kind of legal and compliance related aspects do we need to think about with respect to models? What aspects of monitoring do we need to do? What's our process of deploying various models? So all those kind of become important in the context of risk management from a model risk perspective. And that's kind of the goal of this class, wherein we are kind of bringing you the pragmatic aspects of understanding the key elements which goes into the governance, AI governance, and also the model risk management aspects of it. The reason why this is becoming more and more popular, and you're hearing it on a regular basis, is people are understanding now that it's not just sufficient to understand the model building piece and just focusing on building the best possible model out there. You want to be able to convince that it's ready for production. You want to make sure that you're doing it in a responsible way. You also want to make sure that your end users who are using the models, if they have questions on explainability and fairness, you have the basis to kind of understand what's actually happening with respect to the models you're using, but also being able to provide the required information, either from a regulatory perspective or from an end user perspective. The fourth component, which I used to do a lot in my practice in the past, but now we're trying to make sure that it's becoming more of a science, is this whole notion of stress testing and scenario testing. And in order to make sure that you have the right kinds of tools available, you have to think about what is the role of synthetic data, because many times you may not have real data. So we have some tools available so that you can use synthetic data for testing and for scenario generation. But in addition to that, you have to think about what kinds of metrics of valuation you have to think about in the context of risk. And then also this notion of anomaly detection, because you may not be having all the data to see all the potential anomalies. So what kind of testing do you need to do when you think about building out models? So we have used a bunch of different Python packages and machine learning packages to help kind of build out a structure for stress testing and scenario testing. And that kind of comes into the context of risk, because as a part of your exercise, you will have to think about like what kinds of testing should developers be doing to make sure that the models are robust and functional and you can give certain kinds of guarantees. And then what kinds of testing should the risk managers be doing and the risk professionals should be doing to ensure that the scenarios and the unknowns are kind of captured as you build out the different kinds of models. So we have kind of structured this. And again, many of these use open source Python packages so that you will be able to translate the lessons you learn in here into practice. And then finally, as you can imagine, it's becoming more and more of a norm today to make sure that whatever you are building has a good assessment, which has happened before these are deployed in production. So that's where we are seeing this whole notion of aspects of bias and aspects of security, and a lot of organizations are now citing towards conducting formal algorithmic audits. And we have seen some legislations kind of come up in New York and other places, and this is becoming more and more formal. And the big picture idea is, when you think about transparency and responsible use of AI, you want to make sure that whatever you've been building has been formally tested, formally assessed, but also you have others who may not be involved in the development process can also take a look at it and can attest that you have done a good job in terms of addressing all the potential risks. And many a times, when we work with, let's say, smaller entities, they may not have the right kinds of infrastructure. They may have, built out, tools using low code and no code platforms, and many times they may not understand the entire workflow, and they may be using it in high risk, high criticality situations. And that's where sometimes they may have to go through a formal audit to make sure that they have also all the aspects of risk taken care of. And I've seen a couple of publications in the recent past wherein they're being formally trying to introduce algorithmic audits as a way of assessing and also potentially mitigating risk, because many times you may not be able to understand what potential risks you may be exposed to till you actually get into that kind of an arena. And another aspect is, as you know, there is a huge talent war going on, and people are taking different opportunities. But in the machine learning and AI arena, getting the high level, getting the high caliber talent in every organization is becoming a challenge. And that's where there is an opportunity to kind of upskill yourselves, but also being able to take on different kinds of roles. For example, this role of an algorithmic auditor is becoming more and more formal, wherein you are establishing a practice wherein you are going to go and audit other models which may not be built. And for example, if I was talking to a small bank recently, and they told me that they only had like 2 people in their model risk management department, and for them, it's an extreme challenge if they had to kind of hire PhDs to go and build the models or test the models. So they were basically outsourcing many of the algorithmic auditing work to outside entities. And even in our training programs, we've had people from large consulting companies who have taken this course just to train themselves on how to formally audit models and what kinds of aspects do you need to think about when you're building out auditing for various models. So I think that's going to help you kind of build out the thing. So the whole certificate program kind of enables you to provide you a comprehensive framework to understand soup to nuts from building out various kinds of applications using Python and understanding the ecosystem, building different kinds of models using various frameworks like TensorFlow and scikit-learn and other packages, understanding this whole notion of model risk and what do you kind of need to assess when you're thinking about various aspects of model risk. And then the testing paradigm on what does it mean to test different kinds of machine learning models? And then what does it mean to do formal audits? And in order to facilitate the formal auditing process, what we have done is we've kind of created a bunch of different templates. And the templates will kind of, give you, these are starter templates so that you will be able to kind of, take these templates and build upon them. And we basically have a series of different templates you could potentially use. And then, this one becomes like, okay, so what are the various sources? What are the various strategies, policies, procedures, et cetera, et cetera. And then for monitoring, you'll be able to take out these things. And there are also some open source ones available, for example, data sheets for data sets. So you have certain papers which recommend certain kinds of things. So we've templatized them so that you can get exposure to many of the best practices which are out there. So, so that's kind of, a big picture perspective. I know we are running out of time, but I thought I'll stop here and, answer any questions you may have. If you have any questions, please put them in the chat window, or I know there are a couple of questions in here. So let me answer them one by one, but please feel free to keep asking questions in the way. So would you say it's an applied practical course or both theoretical and conceptual by 18? I hope I pronounced the name right. So this one's predominantly a hands-on course, primarily meant to implement various things rather than a theoretical course. I think there's enough theoretical knowledge out there, and we don't want to create an additional course which will just focus on the theory. But we are focusing mainly on the hands-on materials and the hands-on aspects of building out case studies and what would be applied in a pragmatic world. So a couple of other questions is the Just Enough Python course is a 7.5-hour course. So yeah, so we are actually hosting a live class. It's a one-day boot camp on February the 28th. Yeah, all the details are on our website. But you can also do that course in a self-serve manner if you want to do the on-demand programming. What we're trying to do is not give you everything, because Python itself could be a 1-month course. So we're calling it the Just Enough Python for Data Science. So in the context of risk management, we're giving you an introduction. But if you're interested in a very formal introduction to Python, you can contact us, and if there is sufficient volume, we'll be able to add it to our list of requirements. And a couple of other questions. Could you comment on how Python compares to C# in financial applications? That's a great question. I've built applications in C# and C++ way back in time, and especially if it comes down to trading applications and where performance is very critical. Obviously, C# and C++ are much better choices for implementation compared to that of interpreted languages like Python. Things are changing as the hardware profile is increasing, and then you have more efficient packages which can facilitate processing of big data, etc. But it has to be looked at specifically from an application perspective rather than just doing a feature comparison between two languages. So you start with a use case and then think about the requirements for that particular use case, and then decide which particular applications, which particular language would suit you for that particular job. So I will be posting some of the materials I presented online. And then with respect to algorithmic auditing, so we have just the algorithmic auditing course, or you can take the entire certificate program, which includes all the 5 courses which I briefly mentioned. But the algorithmic auditing course is predominantly meant for people who are comfortable with both the programming aspects of Python, but also the model risk management aspects. So they are familiar with some of the terminologies, and now they are thinking about, well, how do I audit a model? How do I think about assessing the risks of various aspects, and how do I document them? And that kind of becomes more of an assessor's job rather than kind of understanding all the key components from scratch. So if you're doing the whole certificate program, you get all the bases before you get to the algorithmic auditing course. But we have also had people who already have the background of the first 4 courses, and they're just looking at the algorithmic auditing piece. So that's also feasible. Cool. So I think we covered all the questions which were pending. Do you guys have any other questions? Please raise your hands if you have any. Or I hope this informational session was helpful. A couple of key announcements. One is this program is conducted in partnership with PRMIA, the Professional Risk Managers Institution, and people who are PRMIA members will also get continuing learning credits for taking this program. And we're also enhancing partnerships with other organizations, but if that's something of interest, it's a great opportunity for you to both do your learning and also get your annual learning credits. And also, if you go to the PRMIA website, I think they also have some discount codes which you could use to join the program so that you come through the PRMIA channel. So I think there was a question on the actual bootcamp. So let me just type in the link for you. If you just go to QuantUniversity.com, so all the programming details are available there. So you can just click on the data, the Just Enough Python for Data Science course, and you'll have the dates and other aspects available there. Okay. So if there are no questions, thank you so much for attending, and we will have a series of guest lectures, so please stay tuned, and we'll be sending you information for people who have already registered to the Quant University Winter School. You will get a weekly invite for all the guest speakers we're going to have, and I will be facilitating some of the sessions, and also along the way, we will try and include some knowledge sessions for you. But thanks again, and I hope you have a wonderful rest of the day, and we will see you soon. Take care. Bye-bye.